Hello, good evening everyone. Am I audible?
Yeah, good evening, ma'am. You're audible.
Yes.
Okay. Shall we start the session?
Okay.
Okay. Let's just wait for a minute. People are still joining. So I hope all of you have gone through contents of the second week. Today we will be discussing questions related to that. Okay, so let us start. So please confirm if you are able to see my screen. Okay, okay, great. Okay, so just okay. Welcome everyone to live session 2. Myself Shubhi Bansal. I'm your teaching assistant for the course NLP. Hello. Am I audible or my video is stuck? Hello.
Yes, sir.
Ma'am, you're audible.
And visible as well?
Yes, ma'am.
What about my screen? Is it also visible? Can you see the PPT?
Yeah.
Okay, okay, great. So today we will be discussing questions related to week 2. So I hope all of you have solved the assignment. So let us start. So this is the question. I would encourage everyone to give it a try. These are the questions related to the contents that are covered in the second week of the NLP lecture series. So please try to attempt this question and put your answers in the chat box. I'll discuss in a minute. This is the first question. So please put your answers in the chat box. We will discuss it. So I hope all of you are aware what is this Levenshtein distance. We have to convert this word insertion to deletion. And we know that the three operations allowed in Levenshtein are insertion, deletion, and substitution. And the cost they have given as for deletion, they have given 1, insertion also 1, and substitution 2. So now they ask like what can be the distance between the strings insertion and deletion. So please give it a try. D. People say option D. Okay, great. Let us discuss. So, what we can do here, there are two ways to solve this question. So, one can be like, hello, yes, yes, please ask if you have any doubts. Any doubt? Okay. So, there are like, we can either draw a table or go by the simpler way. First, I'll discuss the simpler way. So, we have these two strings, insertion, and we have deletion. And we are to find the minimum distance such that the first string can be, this first string that is insertion, it can be converted to deletion. So if we see these four, these are entirely same, T, I, O, N. You can keep them as is. Okay, and this E also. So for this R, what you can do, you can, what operation we can perform here to remove this R?
Delete.
Yes, we can perform one delete. And similarly, to convert I to D, we can perform one substitution. N to E perform the substitution, and S to L also you perform one substitution. So we have, if we see, we perform four operations. Three are substitution and one is deletion. So three, your minimum distance will be 3 into substitution plus 1 into deletion. That is now the cost of substitution, as we see in the previous slide, what it is given as deletion is 1 and substitution is 2. So we can write 3 into 2 plus 1 into 1, that will be 7. So answer is 7, that is given in option D. So this is the correct answer. Please ask anyone if you have any doubts. Please let me know. Any doubts?
Can you explain this again?
Okay. So we are supposed to find the Levenshtein distance. What this Levenshtein distance is, like you can perform three operations are allowed in this for the conversion of the string: insertion, deletion, and substitution. And in the question here, they have given you the cost of insertion and deletion is one each, and substitution will incur a cost of two. Okay, so now you are to find the distance between insertion and deletion. So how we went about solving this was, we first wrote the string as insertion, then the second string is deletion. So if we see the last four characters, they remain the same. You need not perform any operation. Okay. But if you see this R, can we see any R and the length of the strings? For the first string, the length is 9, and for the second string, the length is 8. So to keep the length same means to convert one to the other, we can perform one delete operation such that the length will be same. This R will be removed. So one delete operation you perform. And then if we come to the starting point, to convert I to D, you can perform one substitution, replacing one character of the first string by another character that might appear in the second string. Similarly, for N also you can perform one substitution. You can replace N with E and S with L, and this E you can keep as is. So how many operations you perform? Three substitutions and one deletion. So that is what I have written over here. 3 into substitution plus 1 into deletion. This is the number of 3 is the number of times you have performed the substitution. And then here, what is this? This substitution is a cost. What will be the cost of one substitution? So that cost is 2. And similarly, the number of the times you have performed the delete operation into the cost of deletion. So that is, one is the number of time you perform the delete operation, and this is the cost of deletion, that is 1. So 3 into 2 plus 1 into 1, that amounts to 7. So the answer is 7. That is option D. If you see here, So I hope is it clear? Who asked the question? Is it clear? Who asked the question? Please tell.
Yes, ma'am.
Okay, okay. So there is also another way to solve this. We can create a table as well. So what we can do, you can create a table also. So let's say there was nothing in the beginning that we indicate by star, and also here also there was nothing in the beginning. And now you can put your first string, that is insertion. Let's say along the columns you are putting it. This is the second way to solve the first question only. So let's say initially you didn't have anything, that was just a star, and now you are having I insertion, you are writing along this insertion. I'll draw two lines above this. So this is. Do you want me to explain the second way to solve this same question?
I think
Yeah,
the first is simpler. We can go ahead with that, right? Any advantage of this method? That
Yeah, maybe
second method.
that helps you to solve the second question. Okay, so first you can give a try, then I will explain that way.
Okay.
So you can try to attempt this question first. So here we want to obtain the optimal alignment between the strings, insertion and deletion. And now he asks what can be the operations that you can potentially perform. Shall I discuss, or you people are still attempting?
Can you once show the previous slide, the table one?
Yeah, I haven't done anything in that. How can this be solved using dynamic programming as shown in the lectures? Yes, I will cover that way also. Okay, I'll cover that way. This one slide you wanted to see?
Yes, ma'am. That is it, ma'am. Thank you.
Okay. So someone is asking how we can solve this using dynamic programming. So let me explain. So let's say for that we can draw this table. Okay.
Ma'am, you can use Excel, no? So that it will be more easier.
Okay, okay. Just a minute. I think I'll explain here only. So let's say initially we didn't have any string indicated by the symbol hash, okay? And along the column we will put our first string, that is insertion. Is my writing readable?
Yes, ma'am.
Okay. So along the column you will put the first string, and along this, what do we say? Along the row you can put your second string. So not able to write it here. Okay, I'll write it here at the top maybe. So this is deletion. Okay, so tell me, like, if I go from this hash to, are you, actually, I don't know, I am not able to write with this pen today. Please cooperate. So this is I-O-N. Okay, so let us say I want to go from this first hash to the second hash. What can I do? What will be the cost here? Am I performing any operation? No, right? So we will assign it as the cost of 0. And if I want to go from this hash to inserting I, what will be the cost? 1, right? Because initially I started with an empty string, but now I want to insert I. So, and the cost for insertion is given as 1, right? So that will be 1. And if I again want to insert n, so that will be in. So first you need to insert I and then n. So what will be the cost here? 2. Okay. And similarly, if you want to insert s, what will be the cost? After you have added I and n, that is 1 and 2, then the cost will be 3. Similarly, for this row, you can fill out simply. That is just the normal operation. Okay, like we are adding the characters one by one. And similarly, like if you have this I and here you are having D, so if you want to go from I to D, what will you perform first operation? Anyone can tell? Please tell.
Substitution.
Yeah, but let's say I in this table, what do? I first a substitution is equivalent to a deletion and then insertion, right?
Right.
So what we can do, I first I will delete this I. From this I, I'll go to hash and then I'll do this D. So what will this be now? Since we are performing two operations, so the cost here will be, what will be the cost here? That will be 2. Okay. And now if I want to go from this I to E, what will be the cost? 3. Why? Because first of all, I will replace this I with D. That is, first I'll replace it by the hash symbol, then I'll insert D. The cost incurred is 2. And for this E, what I'm gonna do, I'm gonna perform an insert operation. So what will this be? 3. Okay. Similarly, for the first row, you can fill it like this: 4, 5, 6, 7, 8, and then 9. Okay. And now what will I do if I want to go from N to D? How can I go from N to D?
Then substitution.
How can I go from N to D?
Substitution again.
Yes. So can we think of it like I have I and N, then I am inserting this D. Sorry, I have this N. Okay. So first of all, I'll perform this deletion operation. Then I will insert this D. That cost will be how much? So first of all, I'll delete this N. I'll delete this I. And then I want to get D. So how many operations now?
3.
Yes. So it will be 3 here, and similarly you will keep on adding it. So this will be 2, 3, 4, 5, 6, 7, 8. Oh no, I think 7 step is there.
Well, we'll come back to this later. We'll go with the next question.
Okay. Uh, you're not comfortable with this way?
No, it's consuming time. We might not have time for that. That's the only reason.
Okay, okay. Okay, then maybe I'll put it in the discussion forum. I'll make the video, or maybe I'll put the solution in the discussion forum, how we can solve it using the dynamic programming technique. Okay.
Sure. Thank you.
So if you have you tried this question too? So I'll discuss this one right away. So we have this string insertion. And now what he wants us is the most optimal way, means the minimum number of operations in which we can get this string. So can you tell me like how we can go about this in terms of insertion, deletion, and substitution? And we can see in substitution is not giving us this option as 3. So I told you one thing, like one substitution is equivalent to one insertion and one deletion. So if you use that technique, what can be the answer? So let us say, yes, please say. So can we do like this? I delete this I delete this N. Okay. And then I insert this D. This E I will keep as is. For this R to L, I will perform what? One substitution. And for this E, I can sorry, I think uh, something wrong is there. So I can delete this I, okay? I can delete this N. That amounts to two deletions, right? This S you can substitute with D. That is your one substitution. So one substitution as of now, two deletions. And this E you can keep as is, and this R you can substitute with L. R you can substitute with L, so now it becomes, so now it becomes, so now it becomes your two substitution. And for this E, because you are still to insert this E, you can perform one insertion operation, right? And this TION can be kept as is. So here the correct answer is option B. One insertion, two deletion, and two substitution.
So how do we know whether that is optimal?
That is optimal. How do you know? Okay, so earlier you think of it like this. I'll give you a little trick here. What we said earlier, 3 into substitution plus 1 into deletion, right?
Uh-huh.
But here, if we see 3 substitution, 1 deletion should be my option, one of the options, okay? There is no such option where it says 3 substitution, okay? Then 3 substitution, 1 deletion. And what I said in the when I was discussing, one substitution can be thought of equal to 1 deletion, 1 insertion. So I can see that there are two substitution options are given. Can I try to break it in this form, like solving by options instead of going by the table way? What can I do? Three substitution are there. So I keep it as two substitution, one substitution, one deletion. This you can replace by this one deletion, one insertion. So what it becomes? Two substitution, this one and one, two deletion, one insertion. Any matches? Option B. That is the same way like you solved here, no? I was explaining here what we just saw. There are no three substitutions given in the option. So I can think of the substitution as being equivalent to one deletion, one insertion. So what I did, two substitution I kept. I can see it in the option. Then this one deletion, one insertion. Already we were performing one delete here, right? When we were to make the length from 9 to 8. So that one deletion and this one deletion adds up, two deletion and one insertion. So option B. Any doubts?
So we, just a thought. So had there been the three substitution option in the given option list? So
Yeah,
we
if
should,
it were given, then you could have simply marked that. But
okay,
it was not given, and if you construct this table in the exam, might, as we saw, we were discussing, it is taking a lot of time. So this is one little trick that can help you out here.
okay. So I can take it as if the direct answer is available, well and good. Otherwise, we can break it into the insertion and
Yes,
deletion.
yes.
Deletion. Okay.
Yeah, we can see there is no ambiguity even if you go by this procedure, right?
Right.
Okay. So, moving to next question. This is an easy one. Please give it a try and put your answers in the chat box. I'm giving you 2 minutes to solve. And please consider these sentences as being prepended, means being prepended with this start token. Just a second. So you can consider this as being prepended with the start token and ending with the end of the sentence token. Similarly here, this is the start of the sentence token and this is the end of the sentence token. Again here, this is the start and this is the end of the sentence token. So now you try to attempt it. So it's 18:30 as of now. I'll give you 2 minutes to solve. Then we will see how we can proceed with the solution. So any answers? 15. Okay. Yeah, Swapan, there will be the recording of the live sessions. They I think we are updating on our YouTube channel. So I'll put the link of my YouTube channel here. I'm updating these recordings over there only. So just a second. This is the link to my YouTube channel, and here I'm keeping all the live sessions recording that I have done so far. So maybe you can take a note of this and I'll put it at the end of the slides as well. So yeah. So coming back to the question, please try this. Okay, so I will discuss it now. People are saying option D, either option A, that is 15, or option D, that is 18. But now let us see if that answer is correct or not. So what are bigrams? Bigrams are like two words taken at a time. So like we start with this. I hope you all have considered this start of the sentence and this token. So how we can create our bigrams for the first sentence? You can think of the bigrams as being like this. S, Alice. This is your first bigram. Then Alice went. This is your second bigram. Then went two. So we are moving it into the window of two. You can think of this like we are sliding the window, like S and Alice, then Alice and went, then went two. Okay, then we have this to the and the cafe. Okay, now and also cafe and end of the sentence token. We are to take the start of the sentence and end of the sentence token. Because why? Because they say we do not perform any pre-processing. So the start of the sentence and end of the sentence tokens are still there. Okay. Now we see the second sentence where we have the starting as start of the sentence Bob. Then we have Bob was. Then we have was waiting. Then waiting for, than for Alice. Okay. And in the third sentence, how we can have it? And also Alice, and then end of the sentence token here only. Then in the third sentence, we have the start of the sentence token Alice, Alice and Bob. See, we are sliding the window. We cannot say like we have considered Alice and now it will be Bob went. and Bob will also be there. Okay. Then we come here. Bob went. Then also I'll write it here. Went to the museum, and then you have museum and end of the sentence token. Now they tell you to find what unique bigrams. So say what are they saying for the following corpus? What is the total count of unique bigrams? Unique means these bigrams should not be repeated. So if we see this Alice went, it is occurring anywhere in the corpus again? No. Went to also not occurring. To the, it is occurring here and also here. So you cannot count the second occurrence of it. You just discard this. Don't count. As of now, we have 3. Then the cafe 4. Cafe and end of the sentence. That is 5th. So from here, we have 5 bigrams. Now S and Bob. Bob was waiting for Alice, and Alice end of the sentence. No repeated occurrences here. Okay. But if we see here, Bob was waiting for Alice. Here, if we see start of the sentence and Alice, already we have seen this occurrence here, and now it is occurring here as well. So this is repeating, not unique. Do not count its second occurrence. Alice and never occurred previously, so we will count this. And Bob went. Bob went there anywhere? No. Alice went was there. Bob went is not there. Went to. Went to already we saw here, and now it is occurring here as well. So you do not count its second occurrence. The museum never occurred before, and museum end of the sentence token. So this is also unique. So we had 5 from here. 1, 2, 3, 4, 5, 6. 6 from here. And from here, 1, 2, 3, 4, 5. 1, 1, 2, 3, 4, 5. So this is 6, 5, 11, 11 and 5, 16. One, two, three, four, five, six. Sorry, here are 6. I didn't count this first. Alice, start and Alice. So it will be 6. 6 and 6, 12 and 5, 17. Correct answer is option C. Any doubts? Hello, am I audible?
Yasumi.
So is it clear to everyone? Please ask if there are any doubts why we counted, why we not counted or anything. See the chat box once if there are any doubts. D, option D. So went to occurring, ma'am, last sentence. Why separating as 2 words? Why separating as 2 words, Vignesh? Why? Because in the question they mention we are to consider the bigrams. Bigrams is like 2 words taken at a time. That's why we are considering 2 words. Then in bigram, we take the probability of next word given the present word. So to calculate the conditional probability, we use bigrams. Okay, that is the some concept that we will see in the upcoming questions. But as of now, you're not required here to calculate the conditional probability or anything. Here they just want to check your knowledge. If you people are like clear enough with the concept of what are the bigrams. Okay. Okay. So I assume there are no doubts. So let's move on to the next question. Okay, there is someone putting some query in the chat box. Yes, Sanjeev, please tell. Please unmute yourself and ask your question. Sanjeev, we cannot hear you. Hello. Sanjeev, do you have any doubt? Okay, I cannot hear anything. So let us move to the next question. So here it asks a trigram language model is what order Markov model? So any guesses? Or if you have gone through the lecture, it is there, I think, in lecture 8 or 9. They clearly mention it. This is a big, very important concept. Trigram language model is what order Markov model? Let me see the chat box if there are any answers to this. Yes, second. Great. So, this is a simple question where they say that any n-gram language model is n minus 1 order Markov model. Okay. So, if now here they say n is equals to 3. Trigram means 3. Matlab n equals to 3 and n minus 1 order Markov model. So if you put 3 minus 1, that is 2. So the correct answer is option D. This is a concept that they discuss in detail in the slides. Why n-gram language model is n minus 1 Markov model. Why? Because let's say I am saying uh, I am a scholar. So if I want to compute the probability of being a scholar based on the conditional probability, what all I will take into account? The previous two words. What is the probability that am and a is occurring given the word scholar? So the conditional probability of the previous two words I will take into account for computing the probability that the scholar comes after am and a. Similarly, what is the probability of a given am, I am? Like I'm going to compute what is the probability of occurrence of a if I was given I am based on the trigram. And similarly, what is the probability of the scholar giving am a? I'm trying to explain it. I'm trying to give an overview why they say that n-gram language model is n minus 1 Markov model. So I hope it is clear to everyone. So second, okay. So now they say you are given this Google Books Ngrams corpus and you are to arrange the words tea, coffee, wine, and juice in the frequency of their occurrence in the Google Books Ngrams. So this is like, I think this URL is not working. We'll check it again once. This URL is working. Okay. So here they want you to find the probability of occurrence of tea, gram, wine, and juice, right? Tea, coffee, wine, and juice. We just put these words here and so now they say that the probability of occurrence for tea, coffee, wine, and juice. This is the order that they are giving to us. Okay. As of the year 2014, tea is occurring with the probability of 0.003, coffee with 0.0048, and okay, let us see for the year 2018. So here we can see that coffee is having the highest probability, then wine, then tea, and then juice. Coffee, wine, tea, and juice. But there is no such option. I think according to them, the correct answer is option C. Don't know which order of the year they are taking. Okay, they are telling us to arrange in the ascending order. So if we are to arrange in the ascending order, I think the answer for this is option C. we go by the ascending order. For year 2011, we can say it's juice, wine, coffee, and tea. Juice, tea, and coffee. So for the year 2011, if you see, the order goes like juice, tea, wine, and coffee. And similar option we have here: juice, tea, wine, and coffee, option B. Since they didn't specify the year, uh, I don't know, but the correct answer is option B here. So please take a note of it, and we were to arrange it in the ascending order just by going at this link. Not a big deal. So moving to next question. Any doubts? Any doubts, anyone? So for the questions numbered from 6 to 9, you are to consider this following corpus. Start of the sentence is given. First sentence is the school was open. Second one is Michael and Zach went to school. Third is the playground at the school was huge. Yes, please tell. You people have raised your hands. Any doubt? DS19. Who is this? Any doubt? Sanjeev, you have again raised your hand. Please tell if there is any doubt. Okay. So the next sentence is the playground at the school was huge. Fourth sentence is Bob and Zach played at the playground. Fifth is Bob, Michael, and Zach were friends. So given these sentences, you are to solve these questions. We are to consider a trigram language model where they clearly define how we are going to calculate the probability of the sentence with its trigram probability and everything. Now, based on this formula, okay. So now they want you to find what is the probability that the sentence begins with the start token. Michael and Zach played at the playground. You have to find the probability in this trigram language model. So please give it a try. I will discuss it in 2 minutes. Please give it a try. I'll ask what is the approach. What is the approach that can be followed for solving this question? They are saying that what you can do, given the if you are to find, originally we compute the trigram probability based on this formula, but for the simplicity in this question, what you can do, for the n plus 1th sentence, you can just consider the probability based on just the previous word. Okay, now you try to solve this question. Any answers? So you people are attempting, or shall I discuss? Please answer. Okay, I'll start discussing this. So if we see here, we are to calculate the probability for this sentence. Michael and Zach played at the playground. And now here he says that in the question you can just consider the previous word. It's probability based on the previous word, just the previous word. So probability of the start token, Michael and Zach played at the playground. You are to find this probability based on the trigram. And what you can do here is, first of all, we will try to compute the conditional probability over here. So what we will do, we will try to compute what is the probability of Michael occurrence given the start token. So how we can do, you can see the count of start token and Michael upon the count of the word that is there in the denominator, that is your start token. Okay. So if we go back to the original set of the sentences, please see the slide. So in how many sentences we see Michael is followed by the start token? Any answers? Please open up your mic and speak. How many times Michael is occurring following the start token?
One.
Only one time, madam.
One. And how many counts of S we have in this entire corpus?
5.
5. Great. So what we can write here is like count of start and Michael is just 1 and count of start is 5. So your probability of Michael given start is 1 upon 5. Now what is the probability of and given Michael? So what will be your formula here? Any answers?
Count of Michael and by Michael. Count of Michael. Count of Michael into and by count of Michael.
No. You just refer to this formula here and then you try to answer. Please see this formula here. For simplicity, WP of W0 given n plus 1, that is equals to this. So what we can write here, that is count of probability of and Michael. So we are to consider what? Trigram language model na here.
Yes,
Right?
madam. Yes.
So here what will come also? Start token will also come, right? Because given what is the occurrence of and given the previous two words, Michael and the start of the token. So now it will be like what is the count of start token, Michael and upon the count of start token, Michael. So what will it be? Let us go to the corpus and see. What we wanted to find, start token, Michael and add, that is occurring only once. And what was there in the denominator? Start and Michael, right? That count is also 1. So what we will write here? 1 over 1, that is equals to 1. Okay. Is it clear? Everyone is there understanding how we are to compute? Okay, so now we want to find what is the probability of occurrence of that given the previous two words. Why just previous two words? We are considering the trigram language model. And here also I explained that n-gram language model, here we are just taking the previous two words, right? Why? Because it is a trigram language model. So here also if we want to now compute the probability of Zach given Michael and, so now what it will be? Count of Michael and Zach upon count of Michael and. That will be the count of Michael and. Okay. So what that count is? Michael and Zach. How many times Michael and Zach is occurring in this corpus? Any answers?
Two times.
Yes. And how many times Michael and is occurring? Please see this corpus. Michael and in a sequence. Again 2 times. Once here and once here. Right? So now what will be the probability here? 2 by 2. Similarly, you will calculate probability of Michael and Zach played at the playground. Played given and Zach. So what will be the probability here? And played Zach? Played and Zach. What is that probability? This is occurring here only once and Zach played. Play. This is 1. And what was there in the denominator? And Zach. So what is the count of and Zach? What is the count?
3.
3.
So what will it be now? 1 by 3. Right? And what if we are to calculate the played at the playground, right? So, so we are also to find played at the playground. So probability of at played at the playground. Michael and Zach played. So you are to find now this. So it will be like count of and played at Michael and Zach played at Zach played. So it will be at and this word instead of this will be Zach played. So similarly, you will calculate the count of Zach played at, and in the denominator you will have Zach played. Like this, you calculate the probabilities for the entire sentence, and at the end, you will multiply all these trigrams probabilities that you had here. Like Michael given S and given Michael and S. This like this component Zach given Michael and played given and Zach. This like this you will multiply all of them, and you will find that the answer comes out to be option A. So please give it a try. Conceptually, if you have any doubts, please ask your questions. Are we clear enough, like how we are computing, why we are taking like this? Please answer. Everyone there with me? Have you understood this question? How we will compute? Please let me know if there are any doubts.
That's fine. But for the bigram model, we will consider only one word, right?
Yes. Then you will not consider start and Michael here. You will just consider the previous word, immediate previous word you will be considering. Yeah. Any other doubts? So let us close the session for today. Already it's around 7. I will share the slides anyways. And this is the YouTube channel where the video will be uploaded. So after the session, if you have any doubts, you can put your doubts in the comment section or you can mail me as well. My email ID is this. Similar to this, you will find the questions in your assignment too. So do give them a try and Let me know in case there is any doubt. Write to me keeping the subject as NPTEL NLP course doubts. If in case you have any doubts, and this video for the every live session recording will be uploaded at this channel. Slides will also be shared by the PMRF office to you people. So then you can refer to these slides as well. You can take a note of this YouTube channel link and the email ID. So I hope today's session was helpful, though there wasn't much interaction today.
And how do you get this slide, ma'am?
I think they will be sharing it with you, right? Or maybe what I'll do, I'll put this link for the slides in the discussion forum by today evening. Okay.
Okay, ma'am.
So any doubts? Okay. Okay, then we'll meet next Saturday. If you have any questions related to this, please write to me in the mail or in the discussion forum. Okay. And for the third week, please try to go through the videos. We'll be discussing questions like this based on the concepts that you have covered in the video lectures, so that we can see to what extent the concepts are getting cleared and we can get our doubts resolved. Okay, then. Thank you, everyone.